Hello everyone, welcome to the Chemistry Chapter 10, Lecture 1. You will need your blank note sheet, maybe a highlighter if you like to highlight. And in the book, Chapter 10 begins on page 319. Alright, also in a little bit I'm going to have you pause and click on the link in the description box of a demonstration. Okay, starting, so this chapter is called Acids and Bases, and starting with the notes, some general characteristics of acids that you are going to need to learn. All right, acids have a sour taste. They conduct electricity in water, even though they're covalent, and they turn blue litmus paper red. All right, that's the video I'm going to want you to watch. General characteristics of bases, right? They have a bitter taste. So when you think of a base, think of soap. All right, and when you think of an acid, maybe you can think of a lemon or lemon juice. So bases have a bitter taste. They're slippery when dissolved in water, and they turn red litmus paper blue. So litmus paper is just a type of paper that's an acid-base indicator, and they come in three types. Red litmus paper, which is really kind of pink, blue litmus paper, and neutral litmus paper, which can show either an acid or a base. So again, go ahead and pause this video, click on the link in the description box, and watch the litmus paper demonstration, which is a demonstration I give in class, but since you're watching this video, you didn't get to see that in class. All right, chemical definitions of acids and bases. So an acid donates a hydrogen ion. So a hydrogen ion is really just a proton. So we call it a proton donator. Bases accept hydrogen ions. All right, so a base gains a hydrogen, acid loses hydrogens. And then a hydrogen ion is simply just a single proton. Okay, so what happens when an acid donates a proton? So I'm going to go ahead and write this reaction out on my whiteboard. So let's say we have HCl, that's hydrochloric acid, one of the most famous acids, you'll have to memorize that, plus water, in this case, is our base. So the products of this reaction are that the acid wants to give up its hydrogen. So it gives it up to water as a base, and that makes water, H2O, turn into H3O plus. Okay, this is called hydronium, which is also a new polyatomic ion you're going to have to memorize. And then what's left is the chlorine ion. So that hydrogen ended up going right here. So we know it's an acid because it gave up a hydrogen. We know it's a base because it gained a hydrogen. All right, so, and that's explained in these two bullet points right here. So since the reason this happens is because chlorine is much more electronegative. So chlorine is much more electronegative than hydrogen. Okay, you remember your periodic properties, electronegativity, the desire for electrons. So this hydrogen is not getting a very good share of the electrons. So if it joins up with water and makes H3O plus, then the hydrogen can get a little better share of the electrons. So that makes it more stable. So that's why this reaction happens. Let's go ahead and draw that reaction out as a Lewis structure. So I have space here for you to do this on the notes. So we know that HCl would look like this, right, from chapter 8 and chapter 9. And we're not going to draw the shapes, just draw these regular Lewis structures. So our water would be like that. And then for H3O plus, oxygen would be in the center. And then we would have single bonds and still one electron pair. But because that H2O gained a hydrogen, which is a positive charge, it gained a hydrogen ion, a plus charge, so now H3O has a positive charge. And then, of course, chlorine ends up with an extra electron, okay, because it gave up that hydrogen. Now it has an extra electron, has all 8, so it has a negative charge. So that's how that works from a Lewis structure standpoint. All right. So where we are in the notes, we are at the bottom of page 1 when water acts as an acid. So water can be both an acid and a base. So I'm going to write out that reaction. So we have H2O. Of course, you don't have to write it out. It's on your notes, plus NH3. Okay, so in this case, water is our acid. NH3 is ammonia, a famous base, all right, used in a lot of cleaners. All right. Since water's an acid, it wants to give up hydrogens. So it gives up hydrogens to NH3, and that makes it NH4. Now, this nitrogen doesn't have enough space in its configuration to take both of those. It can't go to NH5. All right, so what happens is that we need 2 of those. And then what's left is that we have a hydroxide ion. Okay, so this water gave up one of its hydrogens to NH3 to make it NH4. Then what's left would just be if water gives up a hydrogen, then it's just going to be OH. So that's right there. And that's how it works. Okay, we just need to, if you want to know what's the acid and what's the base, just follow the hydrogen. Acids give them up, bases accept. All right, so in this case at the bottom of the first page, water donates a hydrogen to NH3, making NH4 plus, which is, ammonium. All right, on to the top of page 2 in your notes, amphiprotic compounds. So an amphibian can be, both on land and in water. So you can think of that as doing both. And the same thing is true with acids and bases. So an amphiprotic compound, the way you can remember that is, since you probably know what an amphibian is from your biology classes, can act as both either an acid or a base. All right, so just some vocab there for you. Why do acids conduct electricity even though they are covalent? So the process of donating and accepting hydrogen ions creates charged substances or ions. So usually in class, I would demonstrate hydrochloric acid, how it can conduct electricity in water. And actually, it really corrodes my wires when I do that. But I'll just draw out what happens. If you have, what we do is we put wires in a beaker and hook them up to a light bulb and show that the acid can kind of actually act like a wire. But if this is a beaker, what happens if you dissolve hydrochloric acid in water, it splits into its ions. So we have H plus ions and Cl minus ions. And because they are ionic, we have those ions floating around in solution. It will conduct electricity. All right, so you can just draw a beaker, draw that in a little spot on your notes to the side. All right. Determining. So we're moving on down the notes. Determining. All right. Let me improve this. All right. Determining acids and bases from chemical equations. All right, so this is where you're given a chemical equation. You got to decide, all right, what's the acid, what's the base? So one that I have written out here, and I'll go ahead and write it on the whiteboard, is we have H2SO4. That's one of the famous acids you'll have to memorize, sulfuric acid, plus calcium carbonate. All right, that's a base. It's think of Tums. All right, that makes a calcium ion, HCO3 minus, and HSO4 minus. The reason that we know that H2SO4 is the acid is, see, that it gave away a hydrogen and became just HSO4. So gave away a hydrogen. The reason we know CaCO3 is a base is that that carbonate part of CaCO3 gained a hydrogen. So that makes it the base. Now the base isn't always listed second. It's just happens to be that way in our examples. It often is, but you can't tell whether it's an acid or base based on whether it's listed first in the reactants or not. You have to follow the hydrogen. All right, so gave away. This is a better place to put that. Okay, so in the book, we're about to do 3 on your own problems. Open up to page let's see, page 327. So we're going to work these 3 problems on page 327. And all we've got to do, let me check the alignment of my board real quick. All right. What we're going to do is just write these equations out and figure out which one is the acid and which one is the base. All right, so 10.1, look at us, we're already on page 327. Okay, so it says determine the acid and the base. We have HBr plus NH3 makes NH4 plus Br minus, bromine ion. So you can see HBr went just to Br minus. So it lost a hydrogen. Or you can say a hydrogen was donated. NH3 went to NH4 plus, so it gained a hydrogen. So real quick before I give you the answer, which one's the acid and which one's the base? Well, if it donates or loses a hydrogen, it's an acid. And therefore that makes NH3 the base. All right, underneath that, let's look at 10.2, where we have log a reaction here, 3C2H4O2. Okay, that's acetic acid, which is one you'll have to memorize, plus aluminum hydroxide. All right, that makes aluminum acetate. You may remember acetate from your polyatomic ions. Right, plus water. Okay, so you can see that C2H3O2 went to C2H4O2 went to C2H3O2. So it lost a hydrogen, or we can think of it, instead of lost, we can think donated. All right, so, well, once you figure out which one's the acid, you know the other one is the base. All right, so this is the acid, C2H4O2. And here we have the base. All right, so really a pretty simple process. Just follow the hydrogen. All right, real quick, let's do 10.3. Of course, you can fast forward this video through all of this kind of stuff. And it looks like I need to get a new eraser here. All right, let me check the alignment. There we go. All right, 10.3. So we have H3PO4 plus 3KOH makes 3H2O. Right now I'm not worrying about the phase symbols, but those are important. All right. Okay, so let's take a look at this here. So H3PO4 lost all of its hydrogens and just became PO4 over here and combined with the potassium. Okay, so OH, this part, gained a hydrogen and became H2O. OH, add a hydrogen, you have H2O. So that gained a hydrogen. H3PO4 actually lost 3 hydrogens. So we know this is the acid and KOH is the base. All right, and the fact that it gave away 3 hydrogens, we have a special name for that coming up in just a second. So, general rules for recognizing acids and bases. Acids usually have a hydrogen as the first atom in the formula, such as HCl. Yes, that would be an acid. CH4, no. Okay, the hydrogen doesn't come first. Most bases have a hydroxide ion as part of an ionic compound. So NaOH, that's a metal and a hydroxide. That's an ionic compound, so that is a base. But we have an OH here in this CH3OH. That's a covalent compound. That is not a base as far as that goes. There's other bases. Not all bases contain a hydroxide, but a lot of them do. So that's just kind of a way for you to see what's an acid and what's a base without even following the hydrogen. Now, on the top of page 3, we have 8 famous or common acids, and you've got to memorize these, both the name and the formula, and you have to be able to spell them as well. So this will be on the test. We don't have a special quiz for this, it's just on the test. I will ask you a couple of these. The way you pronounce these: hydrochloric, hydrobromic, hydrofluoric, nitric acid, sulfuric, phosphoric, carbonic. Carbonic acid is what you see in carbonated drinks. And then acetic. And so of these 8 common acids, the only one that doesn't start with an H you can see is acetic acid, which is what's in vinegar. All right, so you got to memorize those. A polyprotic acid donates more than 1 hydrogen ion. So H3PO4, for example, phosphoric acid, wants to donate all 3 of those. So it's polyprotic. In fact, we would call it triprotic because it wants to give away 3. Sulfuric is a diprotic acid because it wants to give away 2 hydrogens. All right, but these acids on the left, HCl, HBr, HF, HNO3, they only have one hydrogen, so they are not going to be diprotic or triprotic. They wouldn't be a polyprotic acid. All right, flip in your book over to page 332, and this is how we're going to finish up this lecture, predicting products from acid-base reactions. All right, and I have numbered these reactions, but in chemistry, these reactions aren't given a number. One of them is given a pretty famous name. I gave a number to them just to help you guys out. All right, so excuse me there, I had to take a drink. So the first reaction is one you got to memorize. Acid plus hydroxide base, so it's a base that's got an OH in it, makes a salt plus water. A salt is just an ionic compound. We're not talking about table salts only here. All right, so you've got space, and on your own 10.4 for each of the three reactions. All right, we are on page 332. Reaction A is we want to predict the products, and we also have to balance, of HClO3 and KOH. So this fits reaction 1. Acid, okay, starts with a hydrogen, and a hydroxide base. We have a hydroxide and a metal, so that's an ionic compound. All right, acid plus hydroxide base makes a salt plus a water. We know it makes a water. Let's put that already over here. And we'll figure out the salt now. The salt, so the water comes from the hydrogen and the hydroxide. See how that's HOH? That would make H2O. So what's left would be the salt. So the salt I'm going to circle in blue. What makes up the salt? It's the potassium. The metal goes first, and then the ion. ClO3, your chlorate ion. So we would have K, again we're going to put the metal first, and ClO3. Now we have to get the formula right. We know that ClO3 has a negative charge, potassium has a positive charge, so KClO3 is actually the correct formula. All right, so blue is the base, blue is what makes up the salt. And then red is where your water comes from. Now this one is already balanced. All right, we have one potassium, ClO3, 2 hydrogens, 1 oxygen. We're good to go. We don't have to balance this one. But I always say put the water first and then figure the salt out from what's left of the hydrogen and hydroxide, whatever's left over. All right, let's do another example. So we have HBr, that's one you got to memorize, hydrobromic acid, plus calcium hydroxide. Okay. I'm not gonna use blue and red on this one. So the water comes from the hydrogen and the hydroxide. So let's just go ahead and put it over here. Okay, we have bromine, the salt. I will go ahead and underline them. Comes from calcium. We've already used the hydroxide and the hydrogen, so the bromine. We have calcium. The metal goes first. We know that calcium has a 2+ charge, and if you look, bromine is in column 7, so 1-. So after the switch, we would have HBr plus CaOH2. Then we're going to get the formula here. That'd be CaBr2. Remember, you bring the 2 down here and the 1 down here. plus H2O. We need to balance. I have 2 bromines, so I'm going to put a 2 right there. Now I have 4 hydrogens, so I need a 2 right there. Right? And that would be the reaction. Let's do one more. This special kind of reaction, acid plus hydroxide base makes salt plus water. It's called a neutralization. That's in your notes. We'll get to it in a minute. Reaction. All right, and C is H3PO4 plus MgOH2, magnesium hydroxide. H3PO4 is phosphoric acid. That is one you have to memorize. All right, I'm going to let you guys try this one first. Okay, go ahead and try it. Pause the video, try it, and then hit play and see if you got it right. Okay, let's see if you got it right. Now we know we've got a water. So what makes up the salt? Well, it's not the hydrogen and the hydroxide, it's the other 2 items, magnesium and phosphate. Magnesium is 2 plus, phosphate, and you will get your ion sheet on the test, is PO4 3 minus. So after the switch there, we would have H3PO4 plus MgOH2 makes Mg3PO4, we've got to use parentheses here, right? 2, some of you didn't do that on the final exam. Use those parentheses around cyanide on final exam is what you needed. So bring that 3 here, that 2 here. Now we balance. Well, I've got 3 magnesium, so let's balance magnesium, put a 3. I've got 2 phosphates, so let's put a 2 there. That gives me 12 hydrogens. 2 times 3 is 6. 3 times 2 is 6, so that's 12, so I'd need a 6 right here. And there is our reaction. So that's our neutralization reaction. Reaction 1, 3 examples. Acid plus hydroxide base makes a salt plus a water. All right, pause the video if you need to get caught up, and we'll move on to the next thing. All right, we are all the way down near the bottom of page 3. Neutralization reaction, that's the official name of this reaction 1. Okay, and just get a bullet with a little information. So a cleaner like a Windex is made of a base. It's an ammonia type of cleaner. And most messes are foods that contain acid. So all you do when you spray Windex on something, and I have a little bit right here, all right, to clean this board, all that you are doing is a neutralization reaction if you're cleaning up food off of a table or something like that. And it makes salt plus water, which is easy to be wiped up. Okay, reaction 2. All these reactions have to just be memorized. Acid plus covalent base makes 2 ions. Now, the example that I gave from the notes that's not in the book would be H3PO4 plus NH3. Okay, this is ammonia. That's a really common base. This is phosphoric acid. Starts with a hydrogen, so you can know it's the acid. Also one of the ones you have to memorize. Now that's not a hydroxide base, is it? So it's not reaction 1. It makes 2 ions. All right, makes 2 ions. Well, what are the 2 ions going to be? Well, if this is the acid, H3PO4, NH3 is the base, then NH3 is going to gain a hydrogen. It's a base, so it would go to NH4 plus. Ammonium, one of those polyatomic ions you had to memorize. Okay, what's the other ion? Well, you just take the ion part away from the hydrogens, and you'd have PO4 3 minus. Okay, these hydrogens were given away to NH3. However, nitrogen can't add 3 hydrogens. It doesn't have enough space around it for that many electrons. So what you need is 3 NH4s. Now, how did I know that? Well, this is the balancing trick. You just take the number of hydrogens that you have to give away and make that the coefficient in front of the NH4. So I'll call that the balancing trick. And then PO43 minus is just peeled off of that H3. So I have 3 nitrogens, so I need 3 here. And we are good to go. We're balanced. Okay, so let's do reaction 3. So this one is reaction 2. Reaction 3 is acid plus water. So water is the base in this case. Makes a special ion, hydronium, polyatomic ion, you got to memorize, plus another ion. So if you see an acid and water is a base, these are the products that you have to write out. Okay, so in the notes, we're at the top of page 4. We're almost done with this lecture. I know this one's a long one compared to the other two. All right, acid plus water as a base makes H3O plus an ion. Okay, so our example that's not in the book, not part of the on your owns, would be H2Cr2O7. So you may recognize Cr2O7 as one of the polyatomic ions you had to memorize, dichromate, plus water as our base. So right now I'm just writing underneath this example here. What is the reaction between H2Cr2O7 and water? And we're going to follow our rules for reaction 3. All right, it makes hydronium, so water is the base. We know this is acid because it starts with H. Water is the base. It's going to make H3O. So this acid gives up hydrogens. So what's left is the ion. Okay, this ion, so we have H3O. This ion is Cr2O7, and its charge is 2 minus. You have to put the charges in these reactions. Now we can use our balancing trick here. We had 2 hydrogens. H2O can only take 1, so let's put a 2 right there. All right. Now I also would need a 2 right here to balance it. Cr2O7 is balanced. You have 6 hydrogens over here, 4 plus 2, 6 hydrogens over here, 2 oxygens, 2 oxygens. So that one is good. All right, we're going to finish up this lecture by working 10.5 and 10.6 on page 333. So pause the video if you need to get caught up while I erase. You've got to clean this eraser. All right, the last little bit of this lecture, 10.5, and this is on page 333. We're going to do book examples of reaction 2 and reaction 3. So 10.5, and we're at the bottom of 333 here. What's the chemical reaction that describes the reaction between H2SO4, that's one of your famous acids, sulfuric acid that you have to memorize, and ammonia. So ammonia is not a hydroxide base. So it's not reaction 1, it's reaction 2. Acid plus covalent base, no metals in it. All right, it makes 2 ions. Well, NH3 is a base, wants to gain hydrogen, so it goes to NH4. What's the other ion? Well, we gave away our hydrogens to NH3. So, gained So what's left, what ion is left, it's just SO4 because you gave away your hydrogens. SO4 has a 2 minus charge. Now we got to balance our balancing trick. We have 2 hydrogens to give away, but I could only give away 1. So we're going to use that 2 and make it a coefficient. That way we have enough ammoniums to take both hydrogens. Now we have 2 nitrogens there, so I need a 2 right here, and we are balanced. Okay? And then our last problem, 10.6, right underneath, page 333. Look at us go. All right, what is the reaction that occurs between HI, okay, that's not one of the famous acids, hydroiodic acid. So you don't have to memorize that one. It's also hard to say. So water is a base. We know this is an acid because it starts with a hydrogen. So water must be the base. Okay, this is reaction 3. Acid plus water as a base makes hydronium plus an ion. Well, if I gave that hydrogen to water and made it into hydronium, what's left? It's just I minus. And that is balanced. Look at that. We've got 3 hydrogens, 1 iodine, 1 oxygen. It's all balanced. So that's a pretty simple one. Your homework from this section. So the explaining took much longer than the homework's going to take. Review questions, page 351, 1 through 4, and practice problems, page 352, 1 through 4 also. So 1 through 4 and 1 through 4. All right, make sure to go back and watch this video again for anything that you struggled with, and maybe I went too fast the first time through, but go ahead and watch again anything you need to watch again as you work these homework problems, and I will see you at lecture number 2.